Okay, so for this example, we have an ordinary egg that is approximated as a 5 centimeter sphere. And then we have a initial uniform temperature of 5 degrees Celsius that is then dropped into a boiling water in 95 degrees Celsius. So we want to take the heat transfer coefficient. Sorry, the heat transfer coefficient is given. We want to determine how long will it take for the center of the egg to reach 70 degrees Celsius. So how do we do this now? Uh, We can solve this again using Biot number. We can assume that we can solve this using a log analysis if you want. But definitely if the k is too low, the Biot number will not be less than. So the h is very high, k is very low, we cannot use the log analysis. But we need to still find the Biot number for the lookup table. So the Biot number is equal to HL C over K. So H and K are given, but the LC, what is the LC? So imagine again, no? The LC, the characteristic length for a sphere, no? The LC here is basically just the radius. So you have a diameter of 5, but the radius here is 2.5. No, not 2. No. So this is actually the LC, the radius. So remember that the characteristic length will be always the radius for cylinders and spheres if it is given. No? So we now can find the byte number. So you have 1,200 and then LC is 0.025 meters and then divided by K. So K is 0.627. So it will be where's the value? So you have 2 times 0.025 over 0.627. So you have 47.85. That is a very big 47.85. No? So this is very large. No? It is not less than. No? So it is not less than 0.1. Therefore, this is not lumped system. Okay. Okay, so the next thing we have to really do, or that we never really do much in the first time we do it, is we need to find the Fourier number, no, the tau, which is the thermal diffusivity times the time over LC squared. So, uh, we have thermal diffusivity, okay, and then this is in meter per second, and then the time is, so we don't have a time pala, no? Okay, so we cannot find the tau. Okay. So we cannot find the tau. So we can assume we're assuming that this can be solved, no? And the tau is greater than 0.2. We will check the tau later. Okay. So again, for spheres, to find the temperature difference theta for a sphere, you have a e raised to negative lambda squared tau. Okay, a1 and lambda 1. And then for this one, you have actually sine, right? Well, for a center, it will be, I always forget the formula. Sorry, guys. I'll just check. So for spheres, you have, yeah, you have sine, no? So sine 0, okay. Okay, so this will be 0 over 0. But sine, I mean, if you evaluate this will be equal to 1. Anyways, I'll just write the simple one since we are talking about the center. So I'll just write here center, center temperature. So this will be theta sphere that is 0, and then equals to, you have a1e raised to negative lambda squared, and then tau. Yeah. Okay, and then that's next. That's all, right? That's all, no? For centers. So we can write this, no? So we know that theta of the sphere at 0 is equal to t0 t minus t infinity all over ti minus t infinity. Okay, squared. Okay, so which are given here? So okay, it will reach 70 degrees, so this will be given. T infinity, so the surrounding. So boiling water 95. Ti, the initial temperature is 5. So it is probably from the refrigerator. And then the tau, is it tau given? So we don't know the tau yet, no? But we can find this, no, this lambda and this coefficient using the Biot number. So using the Biot number that is 47.85, we can find the lambda and the coefficient A1. Okay, so let's use this again. We have 47.85. So 47.85, we need to interpolate, no? So we are using the sphere one. So we're looking here, the rightmost part. So you have 40 and 50. So to find the lambda, you have, you just use interpolation here. So 40 and 50. Y is 3.0632. 3.0780. So AC and then shift 155. So you have this 47.85. So 3.075. 3.075. For the coefficient, you can just modify this data. So you have 1.9942 and 1.9962. I think that's it, no? So shift 155 again, and then 47.85. So 1.996. 1.996, yeah. So after doing that, we can also solve for tau, no? We can solve for tau first, and then after that, we can solve for the time. So solving for tau, I think I just shift all this. So you have 70 degrees minus 95 over initial temperature 95. A1 is 1.996, and then e raised to negative 3.075 squared, and then tau, no? So tau is what we're looking for. We can solve for tau. So using your calculators, you have mode 1. So 70 minus 95, 5 minus 95 equals 1.996. E raised to negative 3.075 squared, and then x. So solving for x here, you have 0.208, 0.2086, no? So it is almost, no? So this is still greater than 0.2. Therefore, this is good, no? We can use the formula. No? So now to find the time, you know that tau is equal to alpha t over L squared. So we can solve for time. So time is equal to tau LC squared over alpha. So the tau here is, sorry, we solved this 2086. So dimensionless, and then characteristic length is 0.025 meters. And then you have the thermal diffusivity, so 151 times 10 to the negative 6. So this is in meters. This is in meters squared. This should be squared, sorry. I forgot to square this though. So this is in meters squared. This is in meters squared per second. So cancel. This should be in seconds. So the time can be calculated. Finally, no? 0.2086. 0.025 squared 0.151. So the time needed is 863.41 seconds. No? 863.41 seconds. So the answer key is in minutes. So this should be converted into minutes. So you have 14.39, no? So T is equal to 14.39 minutes. Okay, so this will be your final answer. Okay, so that's all. Thank you guys for listening.